Hello, I'm Tommy Nabil. Now I would like to demonstrate my MC17 project, which I will use the tools MOSCap tool from the NanoHUB online website to explore the MOS capacitor behavior. In this project, I will change the parameter of the MOS capacitor, for example, the acceptor doping concentration of the P substrate, and also the changing the oxide thicknesses of the MOS capacitor. And by change the acceptor doping concentration, I will change the value here to 1 times 10 to the power of 15 to different values, for example, 10 to the power of 17, 18, and also 19. While for the oxide thickness, I will change the thickness to three different values, which are 0.1 micrometer, 0.01 micrometer, and also 0.001 micrometer. And after changing the oxide values, I will do the simulate by pressing this button. And for the result, I will refer the CV characteristic of the MOSCap, which between the gate voltage and the capacitor. From the result, when we increasing the acceptor doping concentration Na to 10 to the power of 90, we can see the CV characteristic of the MOS capacitor shift right a bit, which means the threshold voltage increase for higher value of the Na. This also means that the MOS capacitor also require higher gate voltage to operate in the inversion region due to the surface potential increasing. And for the CV characteristic also, we can see the minimum capacitance will also increase when the Na also increase. And with higher value of the minimum capacitor, the MOS capacitor will tend to form smaller or narrower depression region, which leads to the MOS capacitor to become more faster to transit from the depression region to the inversion region. And for the result, when we're reducing the oxide thickness from 0.1 micrometer to 0.001 micrometer, the overall MOS capacitance will increase, as well as the oxide capacitance. As from the result, when we reduce the oxide thickness from 0.1 micrometer to 0.001 micrometer, the overall capacitance of the MOS capacitor increase, as well as the oxide capacitance. Also, we can see the threshold voltage reduce when reducing the TOX. This means that the MOS capacitor with thinner oxide layer require less gate voltage to invert the channel due to the higher electric field across the thinner oxide layer. I think that's all from my demonstration. Thank you for watching.